Hello and welcome to this Let's Learn Game Dev stream. I haven't streamed in a while. It's been a few bank holiday Mondays, so thanks for joining me if you made it. Thank you to It's ZK Gaming, who is on Twitch and on YouTube, which is pretty cool. So thanks for joining. As always, this is a Learn Game Dev stream. So what does that mean? Well, it means that me, Andy, I will be basically running through some topics, and as things come up that you're not 100% sure about, you are more than welcome to ask questions. That's what this stream is all about, is talking about how we make games, learning the process behind it, and some of the ins and outs of the whole, making games thing, but also specifically about how to use Crayta to do that. So Crayta is a platform where you can play games, you can make games, you can share games. If you are interested in learning how to make games, it's a really great place for you to start your journey in making games. Because it's got a lot of the hard work already done for you. So it's perfect for that. So if you're interested in using Crayta to make games, head over to crayta.com, crayta.com. Go there. You can download it. It's on Epic Games Store for free, or you can use Stadia, where it's also free. Head over to crayta.com. And if you get stuck and you want some more info, then, head over to our Discord, discord.gg/Crayta, which is a fantastic place to get in touch with members of the community, to join up and make games with someone else, to join up and play games with someone else, all of that stuff. So, yeah, welcome to Crayta if this is your first exploration into this. And welcome to Game Dev if this is the first time you've ever made anything, ever. And don't worry, because we'll all look after each other and make sure that everyone gets through this unscathed. It can be scary when you're starting something brand new, or you're early on in your journey in game dev and you're not entirely sure what you're doing or why. But that's one of the best parts, is that first step on a new journey. You'll get there, Hey, Sinjin, nice to see you. Thanks for joining. So, what are we doing today? Well, I should highlight, hey ZK, I should highlight that today we started a game jam, the Perfect Simplicity Jam. So there is a prize pool of $50,000, which is pretty cool. And it started at 11, so you're not too late if you wanted to jump in. In fact, you could probably jump in on the day and still submit something. So, maybe you take 5 days to plan. That's probably a good thing. 5 days to plan, 1 hour to execute. Done. Submit. This is the game jam. You can find all the details on itch.io/jam/Crayta. And if you want to join the jam, I really recommend you join the jam by clicking this button. Get it all set up, get your account set up early on, so that when you're in a mad panic at 5 minutes to 11 next week, next Monday, which is when the deadline is, you don't have to suddenly realize, I need to set up my itch.io account and upload my game screenshots and all that. You will have enough to do at 5 to 11 in the blind panic. Than to to start setting up accounts and go, what background should my account be, and things like that. Get that done early. Join the jam so that's all out the way, and then you can focus on making games. It runs until the 16th, so that's next Monday at 11 a.m. British Summer Time. So just bear that in mind. It's not GMT, it's BST. And the Perfect Simplicity Jam is all about simple games. That could be simple controls, simple concepts, like an easy onboarding, all that sort of stuff. The prize pool's pretty exciting. I'm sure Russ will probably go over this again tomorrow in his stream when he's doing some game dev. It's nice to be back. Thanks, ZK. But yeah, we've got an overall prize. First place is $10,000. So if you make the best game of the jam, then it's $10,000. Second place is $8,000, and third place is $5,000. And then there's all of these great awards, which you might not win first, second, or third, but you could go for one of these awards. It's quite a nice thing to do, is to focus on one of these awards, or several of these awards if you like, and they kind of steer you in the right direction to meet the theme of the whole game jam as well. So things like the single digit award, the best game that can be played with one single finger, which is a great way of thinking about perfect simplicity. It's just, the actual input control being the simple part, whatever you really feel like. Although, don't let that stop you from going off on mad tangents with perfect simplicity as a theme, and just see where that takes you. It's all about flexing your creativity muscles and using the constraints of a jam, like the time constraint, which is 1 week, the theme constraint, which is perfect simplicity, and then even more constraints. If you wanted to go for one of these awards, you can use those to come up with solutions to it creatively. So it's not meant to like narrow you down, but what it is meant to do is make sure you're not starting with a completely blank page, like I can make anything, because that can also that's more difficult to start at that point than it is to start thinking, okay, what are the constraints, what are the parameters that I have to work within. Again, all of the games must be made in Crayta, and if this is your first time looking at Crayta, it would be worth downloading and installing that, or downloading it onto your Stadia account and having a go. Play some of the games that are in there, get a feel for what kind of thing the community like, and make some cool games. ZK, I might join the jam. You should join the jam, ZK. It's great fun. Even if it's just a few hours that you spend making a simple prototype and submit that, it's just taking part. That's totally cool. Or you can do the whole don't sleep for 7 days type game jam, and that's also a thing you can do. Not recommended, but you can do that. Also, I should say, even if you don't get first, second, or third, you don't get any of the awards, there's still 6 $500 runner-up prizes. So even if you spend a few hours making a game prototype, it might be the coolest, most creative elaboration of the perfect simplicity theme anyone's ever seen, and so probably could get a $500 honorable mention if you're lucky. Cool. Hopefully that makes sense. If you've got any questions about the jam, then shoot them to me and I will attempt to answer them, or try and ask someone else who knows the answers if I don't know the answers. I'm hoping I know the answers. I should do, technically. But yeah, the jam, that's a fun thing to do. And there's a whole channel dedicated to it on the Discord, which is the Game Jam channel. So if you're stuck for ideas, or you want to bounce ideas off someone, or you need a partner to make a game with, maybe you're a coder and you need an artist. Maybe you're an artist and you need another artist because you're planning a really elaborate piece of art. That's entirely possible. Anyway, so to go with this game jam that we have, I thought it would be worth us investigating how we can make perfectly simple gameplay controls. So Crayta, by default, let's have a look at Crayta now. I'm just going to open up Crayta. By default, if I just test this is a blank world. This is going to be our sort of, imagine this is our blackboard. We're like in a class, and this is our blackboard that I'm going to write notes on, except I'm not. I'm going to run around on it. It's a different kind of blackboard. Anyway, so what was I going to talk about? Yes, Crayta, by default, uses the PC sort of standard input for any kind of third or first person game, which is WASD. Well, I should say this is the standard Western layout control scheme for a third or first person game, in my experience. Caveats all over the place. WASD to move, mouse move to look around. So using these different controls, I can look around and I can move around. D and A strafe like this. And you think that's quite simple, but then you can also add in shift to sprint, control to walk, C to crouch, space to jump. And very, very quickly, you know, we're like shift, run, and space is like a move where you can jump further. And control doesn't let you walk because you're already at walking pace. Pressing C to crouch doesn't let you walk because you're already at walking pace. So there's all these kind of complexities that we take for granted a little bit, because if you're a PC gamer, or if you're kind of used to games, or if you play on controller and you're used to controllers, you might kind of take these inputs for granted. Like, you've already built up a whole bunch of intrinsic knowledge, which is knowledge that you have that this game isn't teaching you fresh, right? So you might have all of these twitch reflexes, you know, knowing that left click is fire and right click is aim down sight, and all these kind of habits that you've got from playing similar games. And let's face it, they've been using these mechanics, these control schemes for a long time. I don't know, I remember playing Doom with it, Duke Nukem, way back in the day. So yeah, these control schemes have been around a long time. But you kind of have to, for like a perfect simplicity jam, you might want to step back and think, how do I make it even easier? Because actually that's quite a lot going on. You've got the movement, the look around, all of these additional modifier buttons, and then you've got things like shooting a gun, which requires you to move into a position, look in a direction, and shoot at the right time, which can all be quite complicated when you add all of those things together. And it doesn't really matter, you know, who it's complicated for. You know, it's just that is quite a lot going on, and some people might love that stuff and some people might not. And so perfect simplicity as a game jam is an opportunity for you to deviate a little bit in the controls as well as other aspects of the game. And you might not choose to do the controls as the simple part, but that's what we're looking at today. You might choose to deviate, and you might think about how controls could be simplified. There's some great games in Crayta. I can think of like several off the top of my head. One of the ones I really love is this auto runner game. I can't remember what it's called now. Run? There's an auto running game that I absolutely love. Sorry, auto runner, whatever you were called. I should know this. Fun Run. Is it Fun Run? No. Yeah. I think that was one of them. There's lots of, you know, it's a cool game. There's auto runner games. That kind of game where you're like, you one button press to either move left or right or jump. It takes away the whole, like, I need to look in a direction and run, and it turns it much more into a reaction based. I need to time this jump, I need to time this jump, I need to time this jump. You're not just simplifying the controls by removing all of that stuff. You're actually also, the concept of the game simplifies, which means it becomes a slightly different thing, which is cool. It's not like we have to all have the same game, is it? So, in fact, if you want to play a different game, this is a great opportunity to do that. So, yeah. Reducing the controls turns the game into something else, and that opens up loads of avenues to explore. So what I'm going to do today is I'm going to look at a few different strategies we can use to take away some of the complexity around the controls, and by doing that we're going to think we can jam some ideas amongst ourselves. What these new controls, what could they be steering us towards in terms of a game mechanic? So controls are different from a game mechanic. Controls are like the inputs, and we've just talked about that. The game mechanic is kind of the what do you do in a game part. Art is like, what does it look and sound and feel like? And then code is like what is interactable and all that sort of stuff. Game mechanic is what do you have to do? What's the goal? What's the objective of the game? What's standing in your way from that goal? You know, what's the hurdles you got to overcome? Right. Anyway, I've talked loads. That's okay. This is what a stream's about, right? Talk later. Okay. So what I thought we'd do, talk a little bit about simplifying controls, which we've kind of done. One thing I should also add is that I've got notes, which is why I'm looking down here. We're going to talk about that. We've done that. We're going to look at some ways to do it without any kind of coding. And so the first part of today, we'll look at things like really simple stuff. Like if you have a game where you want doors, but you don't want to make your players interact with something to open the door, how do we make it so the door opens automatically? That's a pretty key part. We'll also look at how do you make, I don't know, a cannon fire without coding too much. You know, that kind of thing. So once we've done the non-codey part, where we look at some really simple ways to give interactivity to a game that essentially reduces the amount of controls that a player needs to have, we'll look at some code versions of that. So how do we use code to take control of the controls? How do we use code to override the player's move and look controls and turn it into something else? So rather than controlling this character the normal way, we're either controlling this character in a different way or we're controlling something else in our game. So we're going to try and squeeze all of that into the next hour and a half. Let's see how we get on. Right, to start with then, one of the first things I said was, how do we make a door open? Right, so this is a really simple thing. Like if I put a door down, let's get a door. What kind of door do we want? I'm thinking like, there was these really massive, I probably should use this one. This is the most appropriate. Okay, so this is a door that intrinsically, there's that word again, a player would look at this and go, probably don't need to press a button for that. They might need to press a button, but because of being in, you know, the real world and in society, when we see doors like this, we tend to think, oh, they're automatic sliding doors because they don't have handles. So we're not looking for an interaction. That said, if there was a button next to it, we would very quickly realize, oh, there is an interaction. I need to press the button. Anyway, we're going to use the fact that generally speaking, when someone sees a door like this, they're probably not thinking, how do I interact with it? Let's just build this wall here. Quickly build a wall. This and this. Just so that it's really obvious. This is a door and it doesn't have any buttons. Maybe it's got something in it. Maybe we need to get out of somewhere. I don't know. You choose the narrative for this door. And if we want to open this door, we need to animate it. I could make it invisible, but it's better if you animate it. So let's look at how we do that. The first thing would be, might need to make it animate. So the first thing would be to add a script to it which can animate the door. And an easy way to do that, rather than us writing it, is Adam O's made some great playing scripts by Adam O, who works here actually. He made these playing scripts and they're excellent. So one of them is play animation, one of them is play effect, one of them is play sound. So if you ever want any animation, sounds or effects in your game, that is the package for you. So what I've done there is I just looked for playing scripts in the community and I've installed that package, and what that's done is it's given me a bunch of, well, it's given me these 3 scripts here. So I don't have to actually write anything. They've already been delivered to my game. And with this door selected, I want to add the play animation script to this door. So with the door selected, click Entity, Add Script, Play Animation Script. And at the bottom of the Entity Editor now, I can see that there's this Play Animation Script here. And if I want to play an animation which opens the door, I need to put the name of the first animation which is opening. So when I'm hovering over this copy animation names button, if I click it, it copies the animation names to my clipboard as a list, as you can see there. If I hover over it, it's got the animation names, so I can choose which one I want to use. And I'm going to use the opening one. Open is fully open. Closed is fully closed. Opening is the action of the doors opening, and closing is the action of the doors closing. So if I use the opening word, the word opening there, and the word closing there, that now means that this script is set up so that if I toggle it, it will play opening and then it will play closing. The hard part of this is making it fire those animations. So I've actually written in what the animations are, but I actually now need to tell Crayta when to run those animations. So I've got a script which knows what the animations are, and now I need to say when to run them. And I'm going to do that rather than doing it when I interact with the door or something like that, which is entirely possible. You could do on interact and then bind it to the door, and then the toggle function, and that would work. So let's have a quick test. So now when I walk up to the door, I interact with it, it opens and it closes, and it opens and it closes when I'm interacting with the door. But what this stream is all about is I've just given my player another button they need to press. And in some respects, having a button to press to open a door is cool. It's good feedback because you're pressing a button and something's happening. And that tangible feedback is nice, right? In other respects, it's a limiter because what it's doing is it means that now my player needs to interact like purposefully with something for the door to open. And that, for whatever reason, they might be in the middle of a gunfight. They might be half looking at the game, half looking at their phone. They might be playing the game on their phone through Stadia and, you know, maybe not like, I don't know, not having the standard PC controls. So for whatever reason, they might not want to do that, might not be appropriate, it might not fit narratively. So rather than us interacting with the door like that and forcing our players to press a button, let's instead add a trigger. So I'm going to go to the primitives tab, my library over here. I'm going to choose the trigger and I'm going to place that in the game world. You can see the trigger, it's arrived. There it is. Oh my God, it's so exciting. Let's make it bigger. 200 by 200 by 200. And let's move it up. So the trigger is an invisible volume in my 3D world. And it knows when someone has walked into it or walked out of it. It knows when anything has entered it or exited it. And it will fire these events over here. If I open this up, on trigger enter, on trigger exit. So it fires those events whenever someone walks in or out. And so we can now, let's add it to our spaceship door as a child. And then let's on trigger enter, click the plus and enter a new binding. I'm going to drag my door into entity. It's going to automatically select my play animation script. And my event that I want to fire is play first animation. Now, when I test the game, I'm here, I walk into the trigger, and the doors open. They stay open, and that might be your desired behavior, but for me, I'm going to go one step further and say when the player leaves the trigger, on trigger exit, let's make the door play animation script. Let's make it play the second animation. Now, let's go back to the door quickly. The first animation was opening. The second animation was closing. So when the player enters the trigger, it's going to play first animation. So it's going to play the opening animation. When the player exits the trigger, it's going to play second animation. So it's going to play the closing animation. Let's have a look and see whether that works. So enter the trigger, doors open, exit the trigger, doors close, enter the trigger, doors open, exit the trigger, doors close. my trigger is just a little bit too far one way. So if we look, I need to make sure that my trigger is sticking out a bit more. So let's center it on the door, and let's also increase its size. There you go. So it'll feel a little bit more responsive by increasing the trigger size. There you go. And for some more glorious feedback, we could also add to that entity add script the play sound script. And the sound we might want to play is something like, let's look for door sound, space props door. Open. I mean, these are just great. Let's put that there. So that's my door opening sound. Let's play that as well. So on the trigger, on trigger enter, let's drag that on there. Let's do the play sound script and let's play that sound. So now when I enter the door trigger, oh, so that's one way to reduce the amount of buttons. I don't know why it's being a bit funny. I think my yeah, don't know. That's one way we can reduce the amount of button presses we need to do. So rather than using buttons in our game and interacting with things or having to shoot stuff, triggers is a really good option for automating some parts of what the player needs to do. And it can still feel really nice with a bit of automation. So it can still give plenty of feedback. You can, set off fireworks and the rest of it. Another thing we might want to add to our door here is if we add an effect. Let's do that, and let's just add a little puff, little smoke puff, smoke ring weak. Yeah, something like that. So if we add a smoke ring to our door as well, smoke ring weak, and then again when we open the door, we will play effect, and we'll play that. So now it should play a sound and an effect and open the door, and we're really building up some feedback. And if you look at the code, you can just sort of see it's actually pretty straightforward. So if it's just literally playing the effect like this. So if you wanted to, you could take out of those scripts and you can add to them yourself, and you can go even further than that. So that is just one option. You take triggers and you really start to use triggers to guide your player around, and also to take away some of the interaction that they need to do. Another cool thing you can do is give players options. So you can choose to use triggers, or you might say to them, there's this option or there's that option. So you might say, with the control scheme, you might say press, V to auto run, or press R to auto run, and press R to stop running, and things like that. So we'll have a look at that in a minute. We'll get into using buttons to give our players some different options as well. But the next thing we wanted to have a look at, one of the things was this, and using triggers is a good way to reduce how complex your controls are. But the next thing I wanted to show you is I made this this cannon, and I've made a tutorial. Let me get you that tutorial. So if you look in on YouTube, you can find, let me just get this up, the arcade Crayta. Here we go. So if you're interested in taking control of player inputs, let's just drop that down. If you're interested in taking control of player inputs, I made a tutorial where I essentially took control of player inputs. It's a little bit of a long one. It's 44 minutes long. But what you end up with is kind of a hammer game where you have to hammer the buttons as hard as you can, and then it slams down on the try your strength machine. So that's an opportunity where you can go through that tutorial if you're interested in adding arcadey games to your game, and take control of the controls, of the player controls. But I'm going to have a look at that in a little bit now. So if you ever get stuck and you can come back to this stream, but there is also this tutorial, which is making arcade games. And I will put a link here in the chat. And you can go and have a look at that game, that tutorial. And yeah, that is a way that you can take control of player controls and simplify them. So let's have a look now in real time at what that kind of thing looks like. So in my game here, when you come to make a game in Crayta, you have a couple of things that will already exist in your template drop down here. One of them is the world, which is up here, and that's the world that you'll be editing as usual. If you started from a blank template, then you will only have the world, the player, and the user. If you've installed any packages and they've come with other templates, you might see them. So I've got my animating door there, for example. And I've got a cannon package, which I'd like to show you towards the end. But otherwise, and if you've started from a blueprint that's like a capture the flag or whatever, then you'll probably see a whole bunch of other templates. But anyway. The player template is around your player's character. So when we're in our game, the character that I'm running around as, this person, that is my player. That's represented by the player template in the templates drop down. The user is me, who's sitting at the mouse and keyboard doing all of the game editing and the actual playing. So this kind of represents the person sitting at the controls, and the player represents the 3D character that's running around the game environment. Hopefully I've made that distinction clear. Let me know if that's a bit confusing. And so when we want to take control of the controls, which one do you think we need to take control of? Which one do you think needs the script? The player, which is the character that runs around the game world, or the user, which is the person playing using the controls? The answer is it's the user. And you can actually, if you have a look at api.crayta.com, we can have a look at a couple of the things. Here we go. If we go down to user, we can see there's already API calls where we can take control of controls, or we can override them. So if I just Control F for override, here we can see we've got set move override and set look override. So if we're trying to change the control scheme of our game in Crayta, we're going to need to change what the move override looks like, or we might want to change what the look override does. Move override is moving my character with WASD. Look override is using the mouse to look around the screen. Obviously, if you're on controller, move is left analog stick, look is right analog stick. And so we can take control, we can essentially override those. So let's look at how we do that. So with my user selected, I'm going to add a script. I'm going to click on user, entity, add script, and new script. And this is going to be my input override script. And let's open that up for editing. So the first thing that's worth bearing in mind is if I am going to allow my player to, if I'm going to stop my user from being able to move my player, that's really straightforward. That's self get player, and this could actually be on the player, self get entity, which gets hold of the user, get player, which gets hold of the player, which we were just talking about, and then we can do set input locked. And that is actually a function on the character, not on the user. So that's why we're doing get player. And if we set that to true, it means that whenever I try and press any keys on my keyboard, it shouldn't be letting me do that. Let's have a look at the API docs. So if we go to the character, which is what a player is, lock player control. So that's one thing we should be able to do. Self get entity, get player, set input locked. Another way to do that is to go to your player template and just make the speed multiplier 0 and turn off can sprint, can run, can walk. And if I now press F5, doesn't matter how much I press WASD, I can't actually move. Notice though that when I move the mouse, my player still turns around. So looking is enabled, but move is not. And this could be the start of a game, right? Let's try out with our character. Let's choose our player. Let's grab a cannon. Some kind of this. Let's put that there. Let's put cannon on the player's face. Okay, so one of the things I'm doing here is if I press F1 so that I've got the move tool, and you can see here that relative to my player, so my this direction where the red arrow is pointing is forwards. If I check relative, we can see what direction is forwards for the turret, for the barrel here. So off, forwards is pointing right. So if I want my cannon to point in the direction of my player, let's just rotate that cannon. And now, when it's relative, it's pointing in the same direction as normal. So this is a way that I use to make sure that whatever direction my player is facing, my cannon will be facing the same. Now also, I'm flying. Which is fine if that's what you want your game to do. That's happening because my player is colliding with that cannon 60 or 100 times a second or however much. So we need to not let that happen. So let's just turn off collisions. Let's try that now. Okay. So that in itself, I really want to, okay, I know this is probably going a little bit off piste, but let's just take that cannon and move it up a little bit and forwards a little bit. And let's also use the scale tool. Hey, where'd it go? Oh, I've moved it up too far. I've moved it miles away. Where's my cannon? Go back to player. Cannon. Yeah, that's just a tad too far. There we go. Come back. Don't know what happened there. Okay, so we're back at this. I don't know what's going on. Must have pressed an extra 0. Why not? Just make the cannon miles away. Let's just... what I wanted to do was scale it down a little bit. Move it up a tiny fraction. Oh my goodness, what is going on with my numbers? Let's just move it up 1 click. Interesting. Okay, so 100 is halfway up. Let's just go back to my player. Let's move it something like 180, which I think is in centimeters. Come to think of it, that must be about head height. Cannon face. Okay, just need to move that back just a tiny bit. I'm getting pretty serious about this now. This is an emerging mechanic, and I haven't even covered half of the things I wanted to talk about. Where'd it go? So what you could do as a game, I'm just jamming ideas. I don't know if you guys are, if anyone else is, but one thing you could do is you could use the fact that it takes a second for you to aim in the right direction. Okay, so it's only following the player's body as well. So you would need to, like, yeah, if you wanted to make a face cannon game, which is where I'm kind of going with this now, let's just reduce that to 60. Let's see where that takes us. Yeah, that's better. Now we're talking. So you can use the fact that it takes a second to look to be part of the game mechanic. I mean, this would work if you could move around as well, but I quite like the idea that I'm a stationary cannon head and I need to fire at someone else. So that's one thing you can do, is you can, without code, you can literally just turn off the movement values in the player template, like this. So you uncheck those 3 and put your speed multiplier to 0, and all of a sudden you can make it almost like you're a human turret and you can't move. If I put that stuff back on, then I can do this, which is also which is also fun, but it's less human turret. You know, if I wanted to be a human turret, then I need to turn that off. So that's one thing you can do. So you can go into your player and turn off this stuff to override their controls. Another thing you can do is, if we go back to the user and get in here, we can do, let's say we want our character to only face one direction. So we've looked at how to stop our character moving. Now let's look at how we could stop our character from being able to look around. That is, you need a script on the user to do that. And you need to get hold of the user in that script in the init function, self get entity, set look override. And then it's after a scale and an add. So the scale will be how much it moves according to your usual movement amount. So if you wanted to you could reduce the sort of the speed of the movement by using the scale, but keep the movement itself. So you could reduce or increase the speed of it if you want to keep the scale, if you want to keep the look, by using scale, the first parameter here, scale. So let's look at doing that. Vector.new, and let's make it 0.1. It's vector 2D, because we are talking about the mouse works in 2 dimensions, right? It's on the screen. So it doesn't work in 3 dimensions. There's no depth. It only works in width and height. So we need vector 2D, and then we just say how quickly or slowly, what we want to multiply the mouse by. So let's multiply the mouse by 0.1 and 0.1. 0.1 for width, which is the first parameter, 0.1 by height. And let's just not add anything. Vector 2D dot 0 to not add anything to this. So we're setting the scale of our look so that it moves a lot slower, and it's forcing my mouse to move slower. I can even reduce that even further. Yeah, it's the sort of thing that if you've got like a cannon for a head, then you probably would look quite slowly around. Yeah, that's really slow. I'm now having to take multiple moves of the mouse to move it. And if we wanted to stop the player moving from looking at all, vector 2D 0 means that we're scaling however much the mouse just moved by 0, which means we can't move it. So we can run around, but we can't move the look direction. Hey Marat, how's it going? So that is that's one thing. We are just looking at how we can override the look, how we can override our player controls. We can override their look by using set look override, and we can do that in the init function. Interestingly, if we wanted to make the player look around, force them to spin, let's do that. Input override script on tick. We'll need to do that on tick. The reason being is because we are going to use the second parameter, which adds an amount of mouse movement, of look movement. And if we did it once, it would just instantly do that. But what we could do is we could do it every single frame and it will continuously look around. Let's try that out. Vector2D.new, and we'll just do it in the X direction so they're spinning. Let's add 1. Let's just see what happens with 1 to start with. I'm just making a cannon head game. So it's just so there we are. There was spinning cannon head situation, which is fun. And that's me every single frame adding 1 to the set look override in the X direction. We could reduce that massively. We could add 0.001. That's 1 over 1,000. So a 1,000th of what we just had, and it moves a lot slower. And we could, let's speed that up. Let's fiddle with the numbers a little bit, and let's make it so that it's spinning around at a reasonable pace. Not quite there. Let's do 0.05. And one thing we could do, can we preview? No, we can't preview. There's the player that you can preview from. There. So there you go. There's another possibility you might want to look at. I don't know whether that's going to spark any ideas, but that's on the on tick. So what else could we do with this same thing, set look override? Let's just take that out of on tick, and let's think about, there might be a mechanic where you can't move. Let's make sure that we can't move as a player. Turn all these off and make that 0. There might be a mechanic where we have to look in one of 2 directions. So that is a possibility. And maybe there's just one button to switch between the 2. So input override script on button pressed, button name, and let's just turn off jump of our player, turn off can jump. Let's go back to our user because that's the thing we're editing. And in here, I'm going to say if the button the player just pressed was jump, then, and we'll flick between the two directions. So we'll copy this set look override and we will add 1 to the set look override every time they press jump. I don't know if that works. I wonder how far 1 moves. Oh, that depends on your sensitivity of your mouse, I guess, but interesting. That doesn't stop. Okay. Might need to do like a schedule here. I'm just riffing on this a little bit. Schedule function. While true. No, it's not while true. Just do it once. Wait a second, and self, and then just set that back to 0. Like this. This looks like some kind of power up you might get in a game where, or like a, what's it called? Where you run over a banana skin or something and it spins you around. Let's try that. Spaces jump. Okay, so that's 1. So what if we, instead of doing 1, what if we did 20? Every time you press space. Oh. I mean, it's looking in a direction. I'm going to hesitate and say that's 12 o'clock is behind, or 12 is behind us with my mouse sensitivity. Oh, nearly. Maybe that's the game. Guess the number to make you look behind yourself. Oh, that was close. I think it's 15. That might just be to do with my mouse sensitivity though. That's it. Yeah, so there you go. There's the game. Press space and your character spins round. Which is the thing. I'm going to keep hold of this jump button press tracking thing. So we're going to leave look override for a second. And I think we're going to take a look now instead of look override, which is something you can take control of, even if it's just to make sure that the player can't actually look anywhere else. So right now, I can't move and I can't look anywhere. So I'm frozen to the spot. So maybe if you need to, I don't know, make a completely separate character template, then that might be an option for you. Or like if you want to manipulate the environment without having the character involved, maybe you're manipulating the environment around the character. That might be a fun thing to do using small scale things, like maybe the character is a giant and you're manipulating small things, and you want your character to be frozen. That's how you might go about doing that. Now let's go back to, let's put these all back on and set the movement to 1. And so with look override set to 0, we essentially can't look around. So we're forced in this direction. And so if you wanted to make an endless runner type game where we're running forward, then this would be the way to do it, is essentially set the direction, force the players to look in a forwards direction. And then let's make it so that the character just doesn't stop running forwards, right? That is something we can do. And we do that in our input override script still. So this was our look override. We're going to do the input override for the movement. We're going to do that on tick. But firstly, yeah, we're going to do that on tick. So here, self get entity, set move override. So look, there's set look override there. Set move override is exactly the same. It works the same way. So we have two vectors, two vector 2Ds. One of them is the scale of the movement. So if we say that we move forward at a pace of 1, we can use this first parameter and set it to half, and it will multiply that. So we'll move forward as at a pace of a half if we set this first thing to be a half. If we set it to be 2, then we'll move forwards twice as fast. So essentially, it's our way of scaling that that speed. So vector2d.new, and let's set that to 0. Yeah, let's set it to 0 first. And vector2d, the second one, the add, works the same as the set look override, where essentially this will get added to it. And because we're doing it on tick, this amount will get added to the move override every frame. Now, bear in mind, this is move override. It's working in 2 dimensions because WASD, or the left analog stick, whichever your input is, works in 2 dimensions. There's no depth, not even if you push your analog stick down. Depth is handled by us jumping and gravity bringing us back down. So we only ever are technically moving in 2 dimensions, and everything else is kind of handled by the physics engine and launching and all that sort of stuff. So, so this is a 2D thing as well. We're adding 0. We are scaling our input by 0. We're doing that for both the move override and the look override. So let's just explore what that feels like in the game. Well, I can't look around and I can't move. And so that's what that does, set move override. But what we could do, instead of setting this to 0 in the add parameter, which is the second one here, let's try adding 1 to the Y value. Oh no, my cannon's walked into a wall. Might just take back that wall a little bit. Also, I could just move the player's start location. Let's make sure they got plenty of running room. But they automatically run forwards, right? I don't know why I've still got this cannon as a head. It's just happened. So we've got an endless runner. It's very simple controls. And it's very simple code, I mean. And the cool thing about doing something like this, where we are locked to look in a direction and we are running, is we can now either choose to allow our players to just jump. Let's do that. Let's click on our player. Let's make sure they can jump again. Go on, you're allowed to jump now. And I don't know, let's give them an obstacle to jump over. I feel like a hurdle of some kind. Hey, that'll do. Do you reckon I can jump that? It's like the worst hurdle idea I've ever seen. Who makes a hurdle out of bones? Honestly. It's ludicrous. I really like it as an idea. It's like some kind of weird game. And space. Yay! I call this skeleton hurdles. Yeah, so the cool thing about an endless runner or an auto runner like that is it gives you the sense of being a little bit out of control. Like you're along for the ride. You can't do much about it. That is a really powerful feeling to give your players. And it can be scary, right? Like, what if you put, I don't know, this face here, and that's now looking at you when you're trying to jump over its bones. I don't know where this is going, but this is this is a new game. I'm out of control. I'm sorry, I've got a cannon for a head. I don't know. Yeah, so we've made that's like a beginnings of an endless runner. A Jurassic endless runner, or a scary hell spawn endless runner type game. We've got automated running, and then the player has one button, and that is jump, and they are allowed to jump, and that's all they're allowed to do. Nothing else. No ifs, no buts. You're only allowed to jump. It's all right going at this kind of pace. It's not too scary, but let's just back this up a bit. What if, with our player, what if we say our speed multiplier is 3? That then means that our speed increases. Yeah, it's all of a sudden. It's fine when you're jogging up to some kind of animal skull, a massive floating animal skull. But when you're sprinting at it at full pace, it's a little bit, gets the adrenaline going. It's a little bit more scary. Especially if it had, like, you know, fire coming out of its nose. We'll try it. Yeah, that is a lot scarier. Okay, so we kind of made an endless runner. Now, if you wanted to do, that's one thing. Just while we're on the subject of endless runners, you might be hesitant because of the camera angle. If you wanted to change the camera angle to be side on, go to your player template, choose the camera type as orbit, and if we just press F5 now with the camera type as orbit, I can now look around. So it's worth bearing in mind that you might need to click the camera angle lock checkbox and then tweak the camera. Because our movement is related to the direction we're facing, we need to make sure that the camera is facing the correct direction. So worth bearing that in mind. So if we are behind the camera player, that's totally fine. Makes complete sense. If we want to go side on, we actually need to do that. So we're overriding. Yeah, I think so. We're instead of putting 1 in our vertical set move override addition. Vertical means forwards and backwards, but it's depending on the way the camera is facing. So if the camera is behind the player, forwards and backwards makes sense to make the player go forwards. If the camera's to the right hand side of the player, and ideally you want your players running from left to right, just because that's the normal way. That's just a Western thing. We read left to right, so often we read a scene in a movie or something left to right. I don't know. So if your camera's to the side of the player and you have them running from left to right, then you're going to need to override their movement on the x-axis, so along, rather than vertically, horizontally rather than vertically. And you kind of have to map this 2D like top down, but you're behind the character. It can be a little bit confusing, but essentially, yeah, from left to right, this first one, from top to bottom or bottom to top, this second one here. So let's do camera your 90 degrees, which should be to the right hand side of our player. Let's have a look. Let's see what happens. Oh, was on the wrong side, I think. I was on, yeah, 90 degrees was the other side. Let's do minus 90. Let's see if that's where I need to be. Yay! Huh. Oh my goodness. There you go. So we've got ourselves, I mean, maybe a little bit more distance here. And let's just, should we go back to a bit of a jog? I mean, I won't go back to 100% jogging. There. Cannon head, the runner. Ship it. It's made. That's essentially how you would go about making some kind of endless runner. If that's something that you were interested in making, if you wanted to make a 2D horizontal run along kind of game. Yeah. I wonder if, just for argument's sake, let's see what happens if I... Oh yeah, you can roll, look. Double tap crouch to roll. If I want that cannon, going back to that cannon, if I want that cannon to be fixed on the player's head, I need to do that in code. This isn't really like a lesson in fixing cannons to people's heads, but I feel like it's an important part of this tutorial now. It's come along with us. It's come a long way. So I will do that at the end. I'll do that at the end if I need to. Right. So yeah, don't get distracted. I really want to do that, but we should stay on target. Okay. So we have taken control of player controls, and we've done that by using set look override to choose what direction our player is facing, forcing them to face a direction. And we've also done that with set move override by forcing them, almost like imagine you're forcing them to press forwards on their controller. And we've also noticed that this parameter here, or we noticed that the set move override is contextual. It's dependent on what direction the camera is facing. So you need to bear that in mind if you're changing camera angles or you're allowing your players to look around, then just bear that in mind that set move override will work according to which direction the camera is facing. Cool. Okay. The next thing I wanted to look at, I mean, it's a fun challenge, isn't it? Like reducing the controls to not much. It's fun. I think it's great. The next thing I wanted to look at was if I go to where's my terrain? Yeah, here we go. Let's just calm down on this stuff for a second. I want to get the game back to where it was. Okay, so still got that going on. We can sprint and all those things. Good, good, good. Let's just delete that script a second. Oh, I should return the camera to normal as well. Oh, don't want that. There's something immensely fun about having a cannon head. I need to just stop for a second. So let's return the camera to normal. Right click, revert property. There we go. Oh, interestingly, that's what this looks like from first person. So now I've got the normal camera and I'm running around as I would normally, which is fun. So what was I going to do next? Oh, it was going to be good. Oh yeah, one thing I wanted to look at. Let's just get rid of the cannon off my head. Oh, sad. Don't worry, I'll make it invisible. It's still there. We know it's still there. Yes, my cannon. Another cannon. Believe it or not, there's cannons everywhere. So I made a package, and if you were part of my our workshop that we had on Thursday last week. Is it Thursday? No, the week before. Blimey. We used a cannon package, and I promised everyone I would continue to work on it because there's a specific thing they wanted me to do, and I'm really sorry that hasn't been done yet, but I'm still working on it. It will happen. So this cannon is I've created a cannon package. You can download it. It's called Andy's Cannon, and if I plonk it in my scene and I interact with it, it takes me to this camera angle, but it's broken because I also need to. I'll just show you where it is. Cannon. If I look for cannon, there's two cannons. There's Andy's cannon and there's BK's cannon. So Andy's cannon is this one. Install the package. You can plot the cannon template in your scene, but you also need to click on your user, click on entity add script, and you need the you need to go on player. Click on player, click entity add script, cannon player script. And that just goes, it's there twice. Of course it is. And that just goes on the player. And let's have a quick look at what that does. So I'm interacting with the cannon by pressing E, and now I can press W, A, S, and D. But rather than moving my character around, it moves my cannon around. So it's like a cannon aiming game. And if I click the mouse, it fires. It's actually firing a cannonball. It's just going so fast you can barely see it. Let's fire a cannon at this terrifying skull. I mean, if that had damage enabled, core, it would be damaged. So let's have a look at how I'm doing that, because I'm kind of taking control of player controls, but in a completely different way than I have done so far. And rather than me coding all of that live and spending 45 minutes coding something, I thought it'd be worth us just dipping into this way is another way to do it. And I've done this in a really similar way to that tutorial I showed about making an arcade game. So in here, in this cannon template, let's go and have a look at the cannon template itself. The cannon is comprised of multiple parts. We have this base, which is the cannon, and then we have this part, which is the barrel. And that's what you get by standard in the meshes. The cannon base, which is this part, I've attached a script called cannon script. And it gets quite involved. It's pretty full on. But essentially what happens is when the player interacts with the cannon, it calls the take aim function in the cannon script, which is here. The take aim function then figures out, is there already someone in control of this cannon? If there is, then back off, because there's already someone here. If there isn't someone in control of this cannon, make this person in control of this cannon, make the player invisible, and then set the user's camera to the cannon cam. If I click on cannon cam, all that is a primitive. If I go to my primitives in my library and choose camera, I can click that. I can click in my scene, and I get given a camera. Cameras are really good fun to work with, and if you're ever not sure what the view of the cannon or what the view of the drone is, you can click on the camera and click move drone here, and you get a drone. The drone moves to where that cannon is. The other cool thing you can do, let's say I got my view perfectly positioned. I want the cannon. I want to look at this cannon when I interact with it rather than looking down the barrel. That's the view I want. I can click the camera and I can click move to drone, and now the camera is exactly where my drone was, and it's facing the same direction. So now when I click move drone here, it's moving back to that place. Cameras are great fun. But if we go in this cannon script, we were looking at the take aim function. We are setting our user to use that camera, and then this is the important part. We're sending the set cannon function event, the set cannon event, to the player, to all of the scripts on the player, and we're passing the cannon itself as the entity. So we're calling set cannon on the player from here, on whatever player just interacted with the cannon, and we're passing the cannon as an argument. Let's go now and have a look at the player. Let's have a look at the cannon player script, which is attached to the player. And on the set cannon function, we are just storing what was our previous speed multiplier. Then we set our speed multiplier to 0, which is a really easy way to make sure that players can't run around. And then we're saying set the cannon property of this class to be the cannon that was just sent. So player interacts with cannon. Cannon goes, have I got another player? No, you're now controlling me. It sends an event to all of the player scripts and it says, hey, I'm the cannon this player is controlling. This script that's on the player goes, you're now the cannon that we're controlling. Let me store you in my cannon bank, which has a space of 1, because I'm only allowed to control 1 cannon at a time. And that's what's happening when a player interacts with a cannon. And it moves the drone moves the camera into the right place, and it freezes the player and all of the rest of it as well. Then notice these two functions, on button pressed, on button released. So any button press and any button release is then being sent directly to the cannon. If we look in our cannon script, we've got cannon player button pressed, and further down we've got cannon player button released. So essentially the controls are working in here as usual, like we're just capturing but at this point we can't move the player around and the player is invisible, so we can't even see them spinning. We're capturing all of their button presses and we're sending them back to this cannon script. In here, we then just use that data. I'm actually adding them to an array and removing them from an array when they're pressed or released, and then dealing with that array of what was pressed and released in the onTick function. And this is a pattern. This is a special type of thing. It's called a game programming pattern or a programming pattern. Hey Hey Sil Games, hey Vivalis, how's it going? Yeah, so this way of doing it is actually called the command pattern. If I go to gameprogrammingpatterns.com, this is an immense resource, but basically if you look in here, I would strongly recommend you take a look at this if you're interested in games programming. One of the first things you look at is the command pattern, and it's all about how to take input, which is tightly coupled to something like primary click is fire a gun, and decouple it so that primary click is now its own thing, and then setting it up so that it can basically become its own event. And so if you take a look at the cannon package, it's one way of applying that pattern. You interact with the cannon, that cannon gets sent to the player, to a script on the player. That player script hides the player, stops the player from being able to move, and then sends any further button presses to the cannon rather than moving the player around. Those button presses are then logged by the cannon script, and onTick moves the cannon to face in whatever direction the player is trying to get it to look at, and takes hold of the click when it fires and all of that sort of stuff. So if you wanted more info on that, then take a look at Andy's Cannon, which is a package that you can play around with. I forgot about Andy's Narrowboat. You can also have a look at that. That doesn't have a script attached. I think it's just a boat. I'm not going to install it. Don't. It's not appropriate for right now. But it's, if you're interested in narrowboats, I made one once. Yeah. So there's that way of handling player inputs as well. And I go through the same sort of thing, albeit slightly simplified, in the arcade tutorial, which I alluded to earlier. Cool. So we've got all these different ways of kind of taking control of our player inputs, stopping them from being able to do things, and simplifying stuff. So with this cannon, for example, because the player can't move around, if I interact with it, the player can't move around. All they can do is look left and right, look up and down. And they can't look, I mean, they can look left and right and up and down simultaneously, but it's a little bit janky. But I think that's part of the charm. Like, cannons aren't going to be easy to aim. They're really heavy. So, and it feels quite heavy. So yeah, there's that idea. Did you see that? Shot a cannonball and the doors opened. That's really fun. Oh, quick, open the doors. Cool. So that's another way to take control of player inputs. One last thing I wanted to look at. It's 20 past, so still got like half an hour, which gives us a little bit of time, which is cool. And that is, let's look at changing the player template. Let's say you wanted to have one type of player on cannons and another type of player running away from cannons. So you wanted your normal players, or your non-cannon players, to just be normal and legging it about like this, right? You want your cannon players to almost automatically be on a single cannon. I don't know. Let's say you have some use case like that. So that's going to call for you to have different templates, different character templates, depending on who's logged in. And so those different character templates might have different control schemes. They might have different scripts added to them to override those controls like we've looked at. So if we wanted to do something like that, let's just right click our character. So we're in our primitives tab in our library. We're going to right click the character, create template, and this is going to be called stationary. This is going to be called cannon head character. Okay. So we've created a new type of player. So this is our player. This is a standard one. And this is an exact duplicate of that. Let's go and have a look at it. It should, yeah, that's our normal one. Our player one. Our player's got the cannon player script and our cannon head character has not. So just worth bearing that in mind. But one thing we need to do now, if we've got two different templates, is determine which one our player should be. Now, when I load in, let's just interact with the cannon and see which one it is. If it doesn't work, then we're the cannon head. Okay, so by default, I'm still loading in and I'm still the player template, which is cool. But what if I don't want that to be the case? What if I want sometimes to be the other one? So in that situation, we might need to have some kind of player manager thing, which determines who gets what. Who gets what player. So I'm going to make a little, I've added a locator because this is like an arbitrary thing. This isn't going to be attached to any one specific thing in my game. So it needs like almost like a non-interactive part of my game, which is a locator is perfect for that. And I've added player manager script to that locator. And a function that we might need in here is on user login. And this gets called any script when a user logs in. And in here we could determine what we should spawn as. So let's go and just quickly get up the api.crayta.com. Yeah, if you're enjoying this tutorial, enjoying this stream, want to learn more about game dev, then please don't forget to subscribe and like the video on YouTube or Twitch, whichever you prefer. If you want more, interaction and other people to talk to, and you want to jam some ideas, you want to make some cool stuff, then head over to our Discord, discord.gg/Crayta, and get stuck in with the community. It's a really friendly bunch, and they're making some cool stuff for the Game Jam. If you're interested in the Game Jam, head over to itch.io/jam/Crayta, and you'll see all of the details about the Game Jam. There's a $50,000 prize pool, which is pretty exciting. First prize is $10,000. Yeah. And there's lots of other prizes available too. So definitely go and check that out. And if you've got a few hours, a few days, a week, then that jam concludes 11 a.m. next Monday. So you've got plenty of time to make something awesome in Crayta and submit it to that jam. Where was I? I was talking about user login. Yes. Okay. So that is an entry point to our script. So let's just get this up while I'm browsing it. On user login, called when a new user joins the game, and it gets past the user that has just joined the game. So we will add that as our parameter. User here. And let's say we want our user to spawn. If we do on user login, the Jackie Chan says Holy Grail. API.crayta.com. Yeah. Just have it open at all times, even when you're not in Crayta. That's what I do. What are we looking for? We are going to take control. Spawn. Of our user spawn. Let's just make sure that we're spawning the spawn player. Here we go. Spawn player, despawn player. So we should not be spawning automatically. There's a way to disable this. Now let's just make sure. Yeah. I think a really good way to do this would be to go so on user login, let's go user spawn, and if I type user spawn player, it gives me what I need to pass in. So I need a player template, and that will spawn it at the default locator. If I want to, though, I could supply a player template and a separate locator, or just a position and a rotation. But the important thing is I need a player template. So we could have two templates. Name is normal. Name is normal player. Yeah. Type equals template. We could also have another template, which is name equals cannon head player. Type is a template. Let's do that. User spawn player, and let's just pass self.properties.normal player. Now that we've done that, let's go to our player manager, and let's just put our normal player as our player template. While we're here, we might as well do our cannon head, although that's not used yet. You'll notice that I'm only using the normal player here. So if I press F5, we should notice that nothing has changed. Nothing's changed. Fantastic. Let's now change this to be cannon head player. Oh, not that we'd know, because cannon head is exactly the same. So before we do anything else, let's make cannon head different. How are we going to make it different? How do you think we're going to make it different? We put the cannon barrel. Let's just get hold of this thing. Put that there. I don't know where I am. In some weird situation. Oh yeah, we need to turn off collision. Don't forget to do that. Okay, so I'm normal. Let's go back into here. Let's change this to be cannon head player. Okay, so I have a cannon on my feet, which is fine, but what we need is a cannon on my head again. It's okay to do this twice, right? You guys are with me. Position 160 high? Something like that. Yep. And then it was 65 along this way. Oh no, wrong number. Wrong. So it was 0 there. That, yeah, obviously, because it's left and right. 65 along there. Something's not quite right. I was going to say something's not quite right, but then I can tell you what's, you know. It's not, of course it's not quite right. It's got a cannon for a head. Yeah, there we go. Another thing, I might just make it, I know that it's, you know, some people are going to feel funny about it not being the proper size. Oh, of course, I had it already on my player, didn't I? But we're going to make it half size. I'm sorry. I know you want a massive cannon on your head, but there. Perfect. There. So back to this. So we've got one player with cannon head, and we're able to have either spawn a cannon head player or a normal player. I'm just going to open up the chat again, just because I realised I closed it, and you're probably saying words. We've got one player with which is normal, one player with a cannon head, and let's say we want our. This means now we can choose which one we want to have. So one thing we might want to do is when the game starts, so player manager script init. When the game starts, we just set some boolean. Player is cannon head to true or false. And then here, if we just check that player is cannon head. If the player is, if this boolean is true, then we spawn the player as cannon head and set cannon head to not player is cannon head to false. Otherwise, spawn the normal player and set player cannon head to true. So essentially that will take it in turns as players arrive in the game to turn them into cannon heads or not cannon heads. So the first one will be a cannon head, and then it will flick that boolean to be false. Let's go through the logic quickly. The game starts, so the first player arrives in the game, which means init is run on this player manager script, which is attached to this locator. The reason this runs the first time one person enters the game is because this is like in the game world. So it runs when the game world starts up, and that happens, that game world starts up when the first player enters. Otherwise there would be no world for them to come into. So the game starts up, we set a value of player is cannon head, we set that to true, and we store that in self.player is cannon head, which means that it's now accessible throughout this script, albeit not accessible as a property. So it's like a private property. Then in on user login, we're checking that. We're saying if self.player is cannon head, then, so if that is true, then spawn the cannon head player template for that particular user and set self.player is cannon head to false. Otherwise, if that's not true, spawn the normal player and set self.player is cannon head to true, end there. The next user logs in, and because the first user, this was true, and then it was set to false, the second user that's false now. So it's going to go straight to this else, and then it's going to go through this logic here and spawn them as the normal player. And albeit there's no actual mechanic in this game, there's going to be some players arriving without cannons on their head, some players arriving with cannons on their head. And that is the crux of a possible game. Doesn't have to be a cannon, could be anything that you might want to attach to players. Putting it on their head like that is okay. You know, we've got it just on their head. An even better way, cannon head player script, is to script that, and let's have a reference to that entity. Actually, we're going to need this as a template. So what we need to do, create a template for the thing that we want to attach to the player. So start with a locator, and let's call this cannon head, and we will attach a cannon barrel to this locator. Like that. Make sure that the cannon barrel is facing the same direction as the locator. So remember this relative hack I told you? So you can click relative and then you can see which direction the locator is pointing, and just make sure it's the same direction as the cannon barrel. So you're looking for the red arrows to be the same. If, for example, this barrel, let's turn relative off while we're rotating. If, for example, we had that red arrow pointing that way and that red arrow pointing, we got this red arrow pointing this way and that red arrow pointing that way, just make sure that they're rotated so that they're facing the same direction. And also worth unchecking relative if you're doing that specific part of it. Relative rotation works really well, but not when you want to make things line up like this. So we've got those two lined up. Let's just make sure that the middle of that locator is exactly where we would imagine the player's head to be. So we want the barrel and the fuse to be lined up with that. So the player's head should be amongst that fuse. Let's also just add some spark here. Sparkles. That's not what I want. Sparks breaks. That's the one. There we go. Right, we want that to be 0. Let's just, there we go. Perfect. Cannon head wouldn't be complete without sparkles. We need some kind of sparkle sound as well. Wonder if we can get that. Maybe it's more like fire. Let's just use that on there and then speed it up, I think. Yeah, something like that. Okay, so that's just gone out. We've got that. Now that we've got that that collection of items, let's turn that locator into a template. We're going to click on the cannon head locator, which is exactly where I want to position my player's cannon head. So I can imagine that being on my player's head. In fact, we can do this with my player like this. There you go. So imagine that's on there. Oh, see, that's important. Test it. uncheck collision, make sure that we can put it on their head. And then 0.5. Yeah, that was about right. Actually, it was 0.525 was found to be the most optimal size. Let's just make sure it's on the player's head. Oh. Oh no. Oh, I moved it. Clicked on the wrong thing. Okay, so we needed it at 0.525. But now, it's not matched up to that. Oh, goodness. Okay. Yes. So that should be like that. Just make sure it's matched up with that. And then let's use the magic of the live preview to move it onto my player's head. So I'm imagining that's going to be about right. Okay, let's make it into a template. Cannon head. Oh, cannon head's called everything. Cannon face. barrel head template. Okay, cool. So we've got that as a template. We can delete it now. Go to our player, choose player, add. Oh no, not our player. We need our cannon head character. Remember, cannon head player script. We need a template in here. Cannon. This needs to be our barrel head template. Type is a template. That's not how you spell template. That is. And then, first things first, when this character is initialized, so on this init here, let's do self get entity, which gets hold of the player. Attack. Oh, we need to spawn the cannon first. Self get entity spawn. Do I need to get world? I do. Local barrel head. Get world. Spawn. And then I need the name of the template or the template asset. So barrel head template. And where do I want it spawned? Vector.0. Rotation.0. 0, 0. And then barrel head attached to self get entity gets hold of the player and the socket name head. Let's see whether that works. I wonder if it's going to position it in the right place for me. I don't think that's quite worked how I want it to. Get rid of that. Any errors? Oh yeah, that'll do it. Returning nil. There's no template. I haven't added the template. It's not going to work. Cannon head character. Yeah, I need to put that template in there. Barrel head template. Plop. I mean, it's not exactly 100% accurate, but it's not a million miles away. This is a different game. I like that. What's better with using sockets rather than just attaching it is that now when my player's head looks around, the cannon goes with it. Albeit it needs a bit of tweaking. You know, we need to. So the problem here is that this is up. This is up. So let's. It's going to be easier to like adjust it in the game world. Let's just. So if that's up, it needs to rotate like that. Right? Gone. Wait, did I just rotate the barrel or did I rotate the locator? I just rotate the locator. So the barrel needs to rotate that way. Yeah, something like that. Let's try it. Oh, I didn't pick the template. It's not going to work. It's not going to do anything. Put that in the game world. That's all that's done. Okay, go here. Copy to template. Copy. So that should update the template now, which means it's nearly there. It's just facing the wrong direction. One final thing. It needs to... So if that is down... Oh, do this with numbers. Is that right? Oh, I didn't put the template again. So it will change. Copy to template. I feel good about this. That's another different game. Okay. Yay! Okay, some slight tweaking. It needs to move forwards. And where is the spark? That needs to be on the spark. Needs to go here. Yeah. Okay, F5. Oh, I didn't copy the template. It's alright. There. Okay, so I've made cannon heads the game. And that's essentially what we're after for this week. So, what have we talked about? We've talked about quite a few things. I've spent quite a lot of time playing around with putting a cannon on my head. I hope that's still been valuable. The most important thing we looked at today was how to take the player's controls and essentially override those so that you can control other things in your game. So the first thing was looking at how we can just avoid the problem altogether. So rather than spending hours trying to program something, if we're not familiar with programming or we don't like the idea of programming and we don't want to do that, that's totally cool. A way to make your game simple in terms of controls is to reduce the need for players to actually interact with things by pressing buttons, and instead use triggers so that the way that they control the environment is by moving around it. And that's what the triggers were really all about, is giving your players the chance to interact with the game, but without having to learn lots of complicated controls. So that simplifies it majorly. And then what we did is we looked at using the player template. So again, without any code, use the player template. You can reduce the speed multiplier to 0, and then the player can't move around. And so that's taken away. I mean, we can still look around with a cannon on our head. That's because I was doing it on the player template, not the cannon head character template. So let's just change the speed multiplier to 0. And that means then that I can't actually move. So that simplifies the controls in a different way. I can still jump, and you can turn off jumping if you want. But this is a way of, like, if you constrain yourself and say, all right, I can't move the player, what can I make? That's a really fun and interesting challenge to give yourself as a game designer. What can you make where you can't actually move a player around, but you can look and you've got a cannon strapped to your head? As a challenge. Oh, sorry, little creator. Yeah, I didn't announce the stream. That was really poor form. But it's just coming to a close now, unfortunately. But yes, it will stay up on Twitch and YouTube, so you'll be able to watch it. And if you get stuck or you want to ask me anything, then I'll be hanging out on Discord for a little bit this evening and also tomorrow. So don't hesitate to ask questions. We were looking at player input, and so the first thing I talked about was, just for the benefit of little creator, the first thing I talked about was, rather than spending ages trying to program a solution to this problem, there are some really good workarounds. One of them is to use triggers so that players are controlling the game just by moving. So you're not asking them to shoot things or interact with things or anything like that, but you can use triggers so that they can move around, but they can still interact with the game environment. And there's lots of cool stuff you can do with triggers. I think we're still just scratching the surface, really, of all the cool stuff you can do there. And then I talked about the player template, and you can change the speed multiplier to 0, which forces the player to be locked to their position. Then we did look at some code examples. We looked at the input override script, and we looked at how we can use set look override and set that to 0 to force our player our players to not be able to look around. We also looked at forcing a perspective by using the orbit camera in our player settings, and then specifying a direction using the camera yaw. So 0 will be behind the player, -90, the player will be running left to right, 90 right to left, 180 the camera's in front of the player. So there's lots of cool things you can do where you are fixing the camera to a specific, using the camera angle lock, you fix it to a specific orbit, and then you fix the look override so that the player can't look around, and then you're kind of forcing your player into a one direction only kind of game. And that simplifies in a slightly different way, because they can still run and jump, but they can't look. And so that's a simplified control in another way. Then we looked at using the onTick function with set move override. And what we can do with set move override is, firstly, we can lock the player, and we do that in code, which means we can unlock the player later on if we want to. So that's another way. Instead of using speed multiplier, you can do set move override. But the difference with speed multiplier and set move override, speed multiplier changes how fast and slow we can move, whereas set move override allows us, our script, to take control of the player's controls. So the first value in this is the scale, so very similar to the speed multiplier, how fast or slow we want the move override to actuate. The second value, I want you to imagine it's A and D in the first number and W and S in the second number. So -1 will be as if I'm pressing A, and bear in mind what direction the camera is facing when I press that. So if it's a normal action cam, -1 will make my character strafe left, whereas 1 will make them strafe right. And the second one is like WS on the keyboard, when so that's vertical. So 1 will make my character run forward, -1 will make them run backwards according to the direction the camera's facing. And so this was how we made our endless runner, by forcing this. Let's just make sure that's set to false, so we get our normal player. Let's just make sure the player has the input override script attached. Let's keep that canon script. So with this input override, we can now force our player to run forward.